Hello everybody. Today we are going to extend what we have been doing about finding domain and range on linear functions to find domain and range of nonlinear functions. First, we're going to start out with a quick reminder of what we have been doing in the previous class. We are finding the domain and range of linear functions on this page. Specifically, we are finding the domain and range of y equals 2x minus 3 and the linear function, or the linear equation, x equals 8. Okay, and if you remember how we did that, we are just going to use our graphing calculator. I have one over here to the left. It is not exactly the same as what we have been using, but it is going to be close enough. This is a TI Inspire, and I need to get out of this to get a new graph here. Okay, and we have up here an f1 of x. This means function 1, taking in x as an input. And we're going to be able to type this in just like we did on our last calculator. F of x is the same thing as y, remember, because it's saying that your output is going to be whatever you type in here, and it's going to be 2x minus 3. And then I can graph that. I get a linear equation that looks like that. I'm just going to quickly sketch this on my graph here, and you should on your paper as well. Looks like it goes through negative 3. Okay, not perfect. I'm just going to move that a tiny bit. Looks like it goes through negative 3 and on the y-axis and 1.5 on the x-axis. What am I forgetting, everybody? You are correct. I am forgetting my arrows. And I am forgetting to label my graph. Y equals 2x minus 3. If you notice over here on the calculator, that is labeled as well. It's f1 of x equals 2x minus 3. But they have labeled theirs as well. And they have not put their arrows on because if you trace it, it will actually go on forever. So that's the way that they show that. Okay, so now that I have traced that really quickly, sketched it, I can find the domain and range. Well, the domain and range here are pretty simple, pretty straightforward. I see that in my x direction, this goes left and right forever. So I'm just going to say for domain, all real x. Similarly, on my y direction, I can see that it goes up and down forever. So I can say for range, all real y. Okay. Let's go on to the next one. Find the domain and range of x equals 8. Well, remember, to graph x equals 8, what I am graphing really is a whole bunch of points where the coordinate x, or the x-coordinate, is 8. The point x comma 0 is one of them. The point x comma 3, 8 comma 0 is one of them. 8 comma 3 is another. 8 comma 8 is a third point. 8 comma negative 6 is a fourth. 8 comma negative 10. And we get the idea. It is a straight line that goes through the point x equals 8. Or goes through the point, every point really, where the x-coordinate is 8. Okay, so I have drawn my arrows. I'm going to label this x equals 8. And then we're going to check about what our domain is. Remember, the domain is all the possible x values. Well, if you look at this, there is only one possible x value, namely 8. So my domain is 8. My range, on the other hand, is all of the possible y values. As you can see, y goes up and down forever. So my range is going to be all real y. Okay, pretty simple. What we were doing last class, pretty straightforward. Now we're going to move into a few funkier functions. Okay, find the domain and range of y equals x squared minus 2. Well, it turns out that what we're going to do is very, very similar to what we did to do it for linear functions. We're going to use our calculator off to the left here. As soon as I turn off Smart Ink, we're going to use this to just type in this function here and see what it looks like, sketch it, and find the domain and range. So I come up with a new graph. It's waiting for me to enter it. I'm going to just type in x squared minus 2, and I'm going to graph it. I wind up with this shape here. You will see this many, many, many times as you go on in math. This is called a parabola. It is one of the most naturally occurring functions, most common naturally occurring functions, from everything from bridges to objects falling to you name it, it shows up in nature. So I have quickly sketched this, and all we need to do is figure out what is the domain and the range. Well, the domain is actually pretty simple. It's all of the x values that we can hit. As you notice, we go on in the positive x direction forever. We go on in the negative x direction forever. So our domain is really all real x. Our range is just a tiny bit trickier. As you notice, going in the positive direction, it does increase forever for the y. However, as we go down, we can only go down until this point right here, and we cannot go any further. Well, what is that point? If it's a tiny bit unclear on mine, you can certainly see it over on the calculator very clearly. This is the point right here, y equals -2. So what we're going to say is it is all real y, but with a restriction now. All real y, such that, remember this colon means such that y is greater than or equal to what number? Well, -2. Y can be anything as long as it is -2 or higher. And we move on to the next one. Find the domain and range of y equals the square root of x. I'm going to do the exact same thing. I'm going to go over here to my calculator. I am going to close this. I'm going to start a new one, and I'm going to call it the square root of x. That's not what I wanted to do. I need to get control. There we go. Square root of x. And enter. That is another function that's going to start looking very familiar to you. Basically starts here at the origin and goes like that. And it's going to increase forever. I'm going to do y equals the square root of x. I think I forgot to do that on the last one, so I'm going to go back. Yep, I did. I'm going to say y equals x squared minus 2. And now I'm going to go back to my current function. I have y equals the square root of x, and it is graphed for me. All I need to figure out is, looking at this picture, what is the domain? What is the range? Well, my domain, my x values, I can increase forever, but I can only increase from this point right here. And what is that point? That's where x equals 0. So my domain is such that all real x such that x is greater than or equal to 0, because it can actually be 0. The range is, when we look at it, it can increase forever, but again, it can only increase from this point right here, which is where y equals 0. So the range is going to be all real y, such that y is greater than or equal to 0. Let's just take a quick second to figure out, for the domain, why x cannot be smaller than 0. Think about what would happen if x was negative. You would have y equals the square root of x. Y equals the square root of -4, say. Well, the square root of a negative number is the only thing, if you remember, that makes a number not real or imaginary. Okay? So we cannot get a real number that is the square root of a negative number. Okay? So this is an imaginary number, and so we're talking about real numbers when we're talking about domain and range, and so we cannot get that. And a similar argument would hold for y, which we're not going to do right now. Okay, the next one, find the domain and range of y equals sine of x. I would not expect any of you to know what sine of x is, but your calculator sure does. So what I'm going to do is I'm going to do trig, it's a trig function, sine of x, and graph it. This is what sine of x looks like. It will become your best friend at some point. That point is probably not right now. Okay, but what this does is it moves kind of like this. Okay, clearly I haven't drawn it perfectly because as you can see over here on the window, its minimum value and maximum value are -1 and 1. Okay, so make sure that when you draw it on your paper, the lines do not go above or below -1. Okay, and now all we have to do is once we have graphed this periodic function, that's a trig function, you will learn about this in future courses. All we have to do is figure out what is my domain, the x values. Looks like they can go on forever, so I'm just going to go ahead and say all real x. And my y values, I can only go up and down as far as 1 and as low as -1. Okay, so this is one of ours where we have two restrictions, an upper bound and a lower bound, which we have talked about in class. So we say all real y such that, and remember we put them in order from smallest to greatest, -1 and 1. Y goes in the middle, and I say -1 is less than or equal to y is less than or equal to 1. That's the way I write a range where you have a lower bound and an upper bound. Okay, I'm going to move on. And we have our final one. Find the domain and range of y equals 1 over x minus 2 squared. This is the strangest one that we're going to look at today. And so that's why we have saved it for last. We are going to type this in. 1, sorry. Messed that up for a second. 1 divided by, and I need parentheses around this bottom part, x minus 2, and the whole thing gets squared. Let's see what happens. What in the world is that? Well, what that is a function that looks a lot like this. However, do not draw it quite yet, because I have put these in the wrong place. It is very tough to get them perfect on Smart Notebook, especially when you are using your finger as a stylus, as I am right now. It looks like that, okay? And what this does go on forever, but in a very special way that we're not familiar with, okay? Let's trace this for a second. Let's see if I remember how to do that. Yeah, I'm going to trace this graph. And what that means is I'm just going to use the left and right arrow keys, and you can look down here as I'm doing this. Here's your x value, and here's your y value. Okay? So just watch what happens as I am doing this. I'm going to go, need this back. Let's see. Okay. F1, or my x value continues to decrease, and it looks like it can probably decrease forever. It goes on and on forever. But look what's happening to y. Okay, notice the y value. The y value does get smaller and smaller, but notice what it never does. It never gets below 0. It's just going to get smaller and smaller and smaller and smaller, but never actually touch 0. And now let's see what happens when I go up and keep going in the other direction. Let me see if I can move this a little bit so you can see what's happening. As I continue to go the other direction, my x continues to get bigger, but look what happens to y again. It keeps getting smaller and smaller and smaller, but never touches 0. Okay? So I'm pretty confident that on my y, I can say that y is going to get as big as I want I'm going to move over here. Y can get as big as I want, but it can never get below 0. And in fact, it can never actually touch 0 either, as we saw. So here's what we're going to write for range, because that is the easier one here, I think. This is all real y such that y is greater than or equal to 0. I have purposely made a mistake here. I want to see if you can find it. I'll wait. Well, if you did say that y cannot equal 0, you are correct. The range is really all real y such that y is greater than 0. It can never actually hit 0, as we saw. As we can continue to trace, it just got closer and closer to 0, but never touched it. Now we need to do our x values. The x values, remember, the domain is all of the values that x can possibly be. Here, going left to right. Well, we've already seen that x can go forever to the left, and x can go forever to the right. But look, our graph has something very special in it here that we haven't seen before. It actually has a hole in it. X can get closer and closer to a certain value from the left. It can get closer and closer to the same certain value from the right. And in fact, we're going to trace it here on the calculator in a second. In fact, let's do that now, and we'll try to figure out what value x can get closer and closer to. Now, remember, we're not talking about the y value anymore. We're looking at the x value. And let's see what happens. Okay, we're at 0. We're at 0.9. We're at 1.2, 1.8, 1.8. We are still on the leftward. Right now, we are right about here. Okay? And then what's going to happen as I keep going on my calculator, I am actually going to get to 2.1, but I'm going to jump to where I am right over here now. So what value did I skip in the middle that was not on a graph? I skipped 2. It turns out that these graphs will get closer and closer and closer to x equals 2 from the left and from the right, but they will never actually touch x equals 2. There is no value for x equals 2. And the reason for that is right here in our equation. Look what happens when you plug in 2 for x. Y, let me get my pen. Y equals 1 over 2 minus 2 squared. That's y equals 1 over, well, 2 minus 2 is just 0. 0 squared is just 0. So I wind up with y equals 1 divided by 0. In case you don't remember, dividing by 0 is something that doesn't make any sense. It's something that cannot be done in math. So that's why 2 cannot be a value for x, but everything else can be. Well, to say that something cannot be a certain number but can be everything else, we start our normal way, all real x, and then we just put our single restriction that x can't equal 2. X is not equal to 2. And it's that simple. We are done. The lesson is over.